Hi guys, so we are continuing the GATE 2017 solution. The next question is the product obtained in the following solubilisis reaction. So the racemic of trans, enantiomically pure trans, racemic of cis or mixture of cis and trans of this diacetate. So guys, what will happen here if this undergoes solubilisis reaction? Here this lone pair electron of oxygen assists the departure of this tosylate. So it will attack from, as this is above the plane, so it will attack from above the plane and it will leave. So the intermediate will be this, and it is resonance stabilized intermediate. This is the another resonating structure. So if we draw the resonance hybrid, then we will get this. So this intermediate have plane of symmetry along this plane, and so from this intermediate, if OSE, so this is the resonance hybrid. Now this intermediate has plane of symmetry. So from at this intermediate, if OSE attack from this side, then this bond will open and the product will be here OSE below and here OSE above. Let's say this is A attack, so the product will be A, and another attack is also possible at this side. Let's say this is B attack, so from B attack we will get the product here OSE from below and the ring will open up in this fashion. So here OSE on the above. Now if we determine the configuration of these two center, then we will get this compound is optically active because it has no plane of symmetry as well as center of symmetry. So if we determine the configuration of these two chiral center, then here CIP rule, according to CIP rule, the preference of this group is 1, this is 2 and this is 3. So clockwise rotation, that means configuration R. Now in this compound, this is 1, this is 2, this is 3. Let's say this is below the plane, so rotation is anti-clockwise, so the configuration is S, but as it is above the plane, so the actual configuration is R. So this is RR. And in this compound, here the hydrogen is below the plane, here it is above the plane. So here 1, this is 1, this is 2, this is 3. So this is anti-clockwise direction, so S. And in this configuration, this is 1, 2, 3. So this is clockwise direction when hydrogen is above the plane, so this is also S. So it is SS. So as these two are RR and SS, so these two compound are enantiomer, and the probability of forming this compound is 50%, 50%. So racemic mixture will formed, and this is actually trans. So our answer will be racemic of trans. This will be the answer. So guys, if you have any doubt, please let me know in comment box. Next question, the structure of the intermediate P and the product Q of this following reaction. So as you can see here, that this is a cyclopentanone derivative. This is pyrrolidine in presence of acid, This is an enamine formation reaction. This is a secondary amine, 2-degree amine, and this is a keto compound. So keto compound reacts with 2-degree amine in presence of the acid to form an enamine. So the enamine will be here. The enamine can form in 2 ways. That is, regioselective enamine formation will occur here. That means from this reaction 2 enamine can form. The double bond may be here, and another enamine will also be formed. Where the double bond is here. That is more substituted enamine, that is less substituted enamine. But what will be the major product? Here the less substituted enamine, it will be the major product, because here if this CH3, here the CH3 is in plane, so here the hydrogens are there, 2 hydrogens are there, and these 2 hydrogens will cause a steric crowding in this enamine. But here, as the methyl is projected from above the plane or maybe the below the plane, so here the steric crowding will be less. Here the steric crowding will not occur. So the less saturated enamine will be formed here, and then what will happen? Here a alkyl halide is taken. This is actually so what will happen? SN2 reaction will take place. Simple SN2 reaction. So this will attack at this position, and this will leave. So the product will be this. Sorry, here one CH3 is there. Now if it is hydrolyzed with acid, dilute acid, then this bond will cleave and it will convert to a carbonyl. So this will be the product. Next question. Here 2-butane reacts with this boron, form the intermediate U, then which react with I2 and NOMe, the product V is formed. We have to determine U and V. So this is a very important reaction of boron, as we know that addition of boron hydride is a stereospecific sign addition. So here the BH bond will add to this triple bond in a stereospecific manner. So the product will be C6H11, C6H11. Now if it is treated with I2, then an iodonium ion intermediate will be formed. Now NaOMe will attack here, and one of these bond will attack from this side. This iodonium ion intermediate will open up. in a stereospecific manner. So the product will be this group will be in below the plane, and in plane it will be C6H11, and above the plane CH3, and it is CH3 above the plane, H below the plane. As this group will come from the plane, so this group will be in plane, whereas CH3 is above the plane, it is above the plane, and this is below the plane, so this is below the plane. Now what will happen, this bond will rotate 120 degree, so that this iodine and this bond will maintain anti-periplanar geometry. So this will come in plane, so B C6H11 OMe. So if this is come in plane, so this it was in plane, so it will go above the plane. If we rotate clockwise direction, then this C6H11 will go above the plane, and the CH3 which was above the plane, it will go below the plane, and it is same as usual. Now from this an anti-elimination will take place. So anti-elimination will take place. OMe will attack here, and in this way anti-elimination will take place. Now this CH3 and C6H11, these two groups are on the above, so these two group will be on the same side, and hydrogen and CH3 both are below the plane, so these are on the same side. So this will be the product.